Derive and apply area of a sector. So here we're going to look at how we can derive and apply an area of a sector of a circle formula in radians. So let's draw up a circle. And we're going to do something similar to we did with the arc length formula. So we're going to create a sector with an angle of 1 radian, which will mean this arc length is r. And let's just look at a generic sector where the angle's theta radians, and we actually want to figure out the area of this sector here. So let's label some points. Let's call the center O, and we'll call this point A and this point B. Now we know the area of a circle is equal to pi r squared of any circle, and to derive our sector formula, we're going to use the fact that the ratio of a sector to the entire circle is going to be the same ratio as the angle to the total angles in the circle. So how are we going to write that? So the area of the sector OAB divided by the area of the circle is actually going to be the same as the ratio of the angle of the sector divided by the total angles in the circle, but the angle in radians. So remember, 2 pi is the same as 360 degrees. So the ratio of the area of the sector divided by the total area of the circle is actually going to equal the ratio of the angle inside the sector divided by the total angles inside the circle. So the area of the sector is what we want to figure out. The area of a circle is pi r squared. It's going to equal theta, our angle inside the sector, divided by 2 pi. The pi's will cancel out. We can times both sides by r squared. So we'll get a half times theta times r squared for our area of a sector formula. And it's very important that theta again is in radians only for this formula. So let's see how we can use that. Let's draw up another circle. Let's draw a sector. So let's say the radius is 9 centimeters and the arc length is 10 centimeters. And we want to find the area of the sector here. So we haven't been given an angle, but we have been given the arc length. So remember our arc length formula is arc length equals r theta, and we just discovered the area of a sector is equal to a half r squared theta, and both of these angles have to be in radians. So let's use our arc length formula first, because we know the arc length and we know the radius of the circle, so we should be able to find our angle inside here, which will be theta. So let's plug in everything we know. We know the arc length is 10 and we know the radius is 9. Solve for theta, just divide both sides by 9. So we get theta equals 10 over 9 radians, because whenever we solve this equation for theta, we always get theta in radians, which means we can plug that theta straight in there because it's already in radians for our area of the sector. So area of the sector is going to be half times r squared. Radius is 9 times our angle in radians, which is 10 over 9. So the squared and the 9 are actually going to cancel out. So we get 9 times 10, which is 90. A half times 90 gives us 45 centimeters squared for our area of that sector.